ये मैथमेटिक्स होता क्या है? What is the purpose of calculus, let's say, in real life? Do you understand what philosophy is? I don't know.
God, yeah, I mean, this is a fun part. This human existence, if you think about human existence, if you think about consciousness, that is precisely the manifestation of mathematics. Every decision that human being takes is a combination of countably infinitely many binary decision. What is your definition of God? Because as soon as you say what is your definition of God, then you are first realizing that the definition of God can be subjective.
What was the point, by the way?
The point was this philosophy of life and philosophy of math.
So, hello, sir. How are you?
I'm fine, thank you.
Sir, you are Neelabja. You told me your name is Neelabja.
Yeah, Neelabja Chatterjee.
Neelabja, Neelabjo.
In Bengali, it's Neelabjo. Yeah, masculine name, so ends with O.
All right.
Bengali. Yeah.
So, am I speaking with a mathematician?
Well, not really. I earn my livelihood through mathematics, teaching and research. So that's it.
Academically, a mathematician.
I believe mathematician is a too much high praise for someone. I'm yet to achieve.
तो किसको आप mathematician कहेंगे?
Well, all the legends. I mean, there are too many legends in India, in abroad. So
No. I mean, अगर कौन क्या merit तक पहुंचने के बाद आप कहेंगे this guy is a mathematician?
I mean, well, if you discover, if you get to some result which is worldwide celebrated and add some novel academic or industrial application to the knowledge, then yes, of course, then you can say it's a mathematician's work.
So I could be a mathematician myself, right?
Could be, yes.
If what you said, I fit the bill and I do something.
Yes, of course.
Okay. So, sir, the thing is, see, I'm a teacher. I'm a teacher of mechanical engineering. And it's more about mechanics that we study. And I teach. And the mathematics that we use, unless we do some mathematical modeling, at least for the undergraduate level, we just use the already established analytical formula to get whatever results we want. So when someone asks me, it has been many times, my students ask me, sir, ये mathematics होता क्या है? And I do not have a very appropriate answer. In fact, आज तक मैं Google तक नहीं किया.
Yeah, I mean, truth be told, I haven't Googled myself. Having said so, what is mathematics can be explained to different spectrum of student in different way, age-wise spectrum I'm saying, meaning if a school goers is asking that what is mathematics, so it's basically a game with numbers, right?
It's arithmetic that way.
Essentially, okay. Yes, because until the age of, let's say, the 10th standard secondary board exam, what you were exposed to, it's roughly arithmetic, a bit of Euclidean geometry, yes, and a bit of algebra probably. Yeah, that's what it's usually covered in India, the secondary board until the age of 15. So at the very beginning level, meaning when you are in the primary school, you are basically dealing with numbers, only numbers, where there you have only arithmetics, right? And then you are trying to solve equations using that arithmetic. So that's where you are getting into accustomed to algebra, right? And then you are jumping from numbers to more abstract figures, right? That's where geometry kicks in. So the higher you go up in mathematics, more abstraction kick in, okay? It gets more abstract and it's more about pattern recognition, okay? So for school students, it's more about pattern recognition in numbers and in figures. The more higher you go up, so in 11th standard, 12th standard, that's where you add a little bit of quantification also. Because for 12th standard people who are studying mathematics, you don't know if they are going to work in mathematics or not. If they want to become an engineer, they have to apply their mathematics, right? So that's where calculus also kicks in. So mathematics for the school students, it's more or less pattern recognition between numbers, figures, quantifying regular process which we are surrounded by in our daily life, and the higher you go up in my mathematics, because
or deeper you go, or you
yes,
narrower you go.
I mean, it's somewhat a pyramid structure, because mathematics has a lot of parts, and
Okay.
I'm
Higher you go, narrower you go.
Yes, exactly. In some sense, yes. I mean,
somewhere arriving to a point. I don't know if I'm making sense.
yeah, sure. I mean, yes, of course. It's more like, so there is this Jatak tale about touching the elephant from different parts, right? Everyone is touching the elephant from different part, but they are seeing different parts of it, but they are touching the same element. So it's from there.
So my question would come more from the space of being a layperson. Please do not assume me as an engineer here when I ask you, because I want to address to everyone.
Yeah.
So what have I understood here is it starts with arithmetic.
Yes.
Arithmetic is numbers.
Yes.
Right. And when you represent arithmetic in its equation form, algebra comes. Numbers become letters.
Yes.
I mean, you represent numbers through letters. Or
I mean, there is an unknown variable.
Okay, that's why we need letters.
Yes, exactly.
Okay, so to find the unknown, we need a variable.
Yeah.
And that's where algebra comes.
in.
Okay. And then when you represent that in the form of geometry, geometry by itself is science. Then, as you say, Euclidean geometry, then the geometrical aspect comes.
Yes.
That's till class 10.
Yes.
And till class 10, it's I mean, how do I put it? It's called mathematic. No, I forgot about it. Like for CAT exam, let's say, for common admittance for all these MBAs,
that
is called quantitative aptitude.
Right.
And most of the questions come within this bracket only.
Yeah.
They don't go to that abstract system that we're saying, where calculus jump in the picture.
Correct. That's very correct.
Yeah.
I mean, that's why, I guess, that's why until 10th standard, what you need is the bare minimum mathematics that should be good enough for your
life survival.
Anyway. For surviving life, yes, it should be good enough, yes.
So somebody who's not good at maths at least till the 10th level, थोड़ा सा वो कमजोर रह गया.
Of course. I mean, see, there are two parts about life. One is survival, one is thriving. So the better you are in mathematics, or to be precise, mathematical reasoning, the better chance you have in thriving in your life. That's how I would look at it.
All right, sir. So for me as a student, till class 10, maths was like Hindi में बोलते हैं ना बाया हाथ का खेल. I used to score 100 out of 100. Okay. Seriously. It's the 11th which pushed me to my limit.
Yep.
Sudden jump to calculus, and I was like, मुझे कुछ समझ नहीं आ रहा था. Although I was practicing it, but comprehension मेरा उस समय में I was a young teenage man, तो समझ कम होता था इधर में. तो वो अभी समझाइए आप फिर से सबको जो भी क्लास 11 12 में होगा. What is calculus?
Okay, calculus is basically quantifying infinitesimally small change in the process which are surrounding our day-to-day life.
Infinitesimally small means as small as you want.
As small as you want. So there was this weird sort of puzzle or puzzle-ish. It doesn't have real much effect, but anyway, I mean, think about it. You have a frog in one end of your room. The condition is the frog can jump as the half of the length it can see.
Okay.
In a finite length room, how many steps or how many jump the frog will take to reach to the other end?
At least for first half he can confidently, because he can see the room.
Of course. But the point is, in real world, after a finite jump, it will reach the the boundary, right? In mathematics, that's slightly vague. Why? Because it can see certain length. It will jump only half. So after a certain point of time, it can see the end, but it will never reach because it can jump only the half. Correct. Right. So this the idea of infinitesimally small is very, 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 it's a very, very original, and it's one of the cornerstone to understand mathematics. So let me borrow one of my teacher who said like how to see this infinitesimal thing. It's about God. In every religion, you have God and some priest, mullah, padre, this profession, right? They are looking for God. They are trying to meditate between you and God. Now, if you ask them that, have you seen God or have you touched God? If you ask any monk, any nun, any sage that have you touched God? Have you seen God? Have you shaken hand with God? They will say, no, I'm trying, right? So that's the difference between infinitesimally. I mean, you can go as close as you want, but you are not touching it. That's what limit is in your 11th standard, if you remember.
Yes, I do remember
Right.
that.
So if you think about, if you ask Virat Kohli that have you become Sachin Tendulkar? Have you become Sachin Tendulkar? He will probably say no out of respect. We as observers, we will say probably yes, probably no, probably he has crossed Sachin Tendulkar. But from Virat Kohli's perspective, he has become as close as he wants to Sachin Tendulkar, but not exactly Sachin Tendulkar.
Can he ever be actually?
Well, that's
Not Virat Kohli per se. Okay, coming to that frog wall example, I mean, it hooked my brain actually. It's quite interesting. Suppose he had like eternal length ka hai,
Yeah.
he can only see the half.
Yeah.
So at max, at one instant, he can reach here only.
Right.
And then he will see this length.
Right.
उसका half तक ही पहुंचेगा.
Right.
यहाँ तक पहुंचेगा.
Right.
उसका फिर half तक ही पहुंचेगा.
Right.
Actually पहुंचेगा ही नहीं.
Exactly. So at certain point of time, his jump will be very close to zero.
Exactly.
His jump will be very close to zero.
As good as zero.
Exactly. As good as zero, but not equal to zero.
Yes.
Okay. So that's what limit is all about.
तो लिमिट से ही आपका कैलकुलस.
Exactly. Infinitesimal change. As the moment you realize this infinitesimal change, life is sorted.
What is the purpose of calculus, let's say, in real life,
Oh.
general life basically, general lay person's life who has got nothing to do with mathematics?
Okay. I mean,
Whatever you say could come out through the academic lens,
right.
but consider yourself to be illiterate. Now,
Well, then calculus, it's a bit tricky because until and unless you are in a profession where you are observing certain process, okay, it will be tricky to incorporate calculus.
attempt, let's see, if you come out with something.
Okay. Let's see. So let's say you are how to say you are a finance guy.
Okay, taken.
Okay, and that means in your modeling, as you said, the known formulas. Okay, so for finance there is this known Black-Scholes model, stochastic differential equation, and so on. So there are a lot of variants of it. Now, how it is coming? You are saying that it's a known formula.
Yeah, I'm claiming that. Yeah.
You are claiming it's a known formula, and that's a finance guy. He's also claiming Black-Scholes is a known formula. But if you ask, can you see how it happened, or can you do it this known? Can you explain this known part without calculus? Probably it will be gone.
I kind of understood what you mean. It's just again I can bring your example of the frog thing. You know that the frog will end up there.
Yeah.
If I take that length.
Correct.
But how did he end up there?
Yes.
Requires calculus.
Exactly. Yes.
So that ending, reaching there as the end point is the known thing.
Yes.
But the approach towards it, the entire journey needs to have some approach. Needs some modeling. But calculus. Yeah.
Yes.
Yeah. सही समझा ना?
Yeah.
हाँ. तो calculus में आपका integration और differential equation होता है.
Right.
And not
differentiation, integration, differentiation, integration.
हाँ, sorry. तो आप उनको भी एक एक करके थोड़ा सा layman person से बताइए, क्योंकि दोनों अलग हैं फिर.
Okay, so
बाप माँ तो एक ही है, लेकिन दोनों अलग अलग बेटे हैं.
Not only अलग अलग, I mean they are basically particle and antiparticle. So they are inverse process to each other. So think about it. In school, what children have done, if you have lot of things, you add them, right? And if you have lot of things of same type, there is the shortcut for addition, that's multiplication. Multiplication is the shortcut for addition. Agreed?
Absolutely.
This much fine. Now, when you are adding or multiplying this thing and the object that you are adding or the objects that you are multiplying, when they become infinitesimally small, very small, then it becomes integration. Okay. So you have addition, shortcut is multiplication.
उसका multiplication का भी shortcut आपका power में.
Not exactly shortcut. Here you have to introduce the notion of continuum. If you are aware of physics.
Yeah.
So continuum.
We assume that it is continuous.
Exactly. If something is continuous, then this multiplication becomes integration. So for instance, you want to measure the area of this table, right? What you are going to do, you are going to consider strips, strips, and then you measure the area of each strip and you sum it up. The moment this difference of strips becomes very small, that is infinitesimally small, you do it integration, right? So that's what integration is all about. Addition, multiplication, take a continuum jump, it's integration. The opposite thing for differentiation, meaning instead of adding, previously what you did subtraction. Now shortcut for subtraction when you have similar type of object was division.
Correct.
Now when you are doing at the infinitesimally small level, it becomes differentiation.
यहाँ तक भी comprehensible है, मतलब understandable है.
Okay.
Then you go double integration, double differentiation.
Yeah. So basically, what happens? You are doing it in 1 dimension or 2 dimension. How many variables do you have? If you have 1 variable, 1 dimension, it's 1 integration. If
इसको भी आप थोड़ा आराम से explain कीजिए मेरे audience के लिए.
Okay, let me try. I don't know how if I can, but anyway, think about this. So as I said, one of the immediate application of integration is measuring the area, correct? Now, when you are measuring the area, what are the components you have? You have can they see this thing? Can they see this?
Okay. मैं इसको मैं try.
Oh, here we have our blackboard. So you have one axis here, you have another axis here. You want to measure the area between these two parts. So how many boundaries you have? 1, 2, 3, and 4. Right? So this horizontal axis is your independent variable, vertical axis is your dependent variable. Horizontal value is moving from one point to other point. You are observing your dependent variable is varying from which point to corresponding which point. Now the question arises when you have more than one independent variable. So think about it. You have your umbrella shaped domain. You have an umbrella shaped domain. Your salad bowl. So everything around us, it's in 3D, right? How much amount of water we can keep in this glass cup, or how much amount of salad we can put in our salad bowl. So that's where area will be not suffice, right? You need volume. So that's where double integration will come in. Again, what you are doing, in case of area, you are taking one-dimensional strip. In case of double integration, you are doing a plane. You are taking a cross section. You are calculating the area of that, and then you are summing it up along the height, right?
Yes.
So when you are doing both at the continuum level, it becomes double integration.
Okay. Again, let me try to review what you have just said.
Okay.
फिर ये suppose मैं start from 0 से करता हूँ. Point.
Yeah.
This is one point.
Correct.
Another point, and they're stacked alongside each other.
Yes.
And if they take a linear path, this point becomes a line.
Right.
So line is nothing but a collection of points.
Yes.
All right. Let's say this line collection of points का मैंने एक length दे दिया. Let's say 5 mm. Let's say 5 mm. And इसका thickness supposedly कुछ है. Whatever unit thickness. उसका ऊपर में और एक stack कर दिया.
और एक line.
तो मैं 2 line हो गया.
Correct.
तो 5 mm plus 5 mm हो गया.
Correct.
तो 10 हुआ. करते यहाँ तक पहुंचा.
Right.
तो मैं देखा कि यार बस कितना ज़्यादा लाइन्स है.
Right.
5 लाइन्स है.
Right.
तो 5 into 5 हो गया.
That's correct.
Shortcut to what you said.
Multiplication, and then you are considering lines of infinitesimally small thickness.
उसमें integration आ गया.
Correct.
अभी यही एरिया को ही वही सेम एनालॉजी लेके यहाँ पे मैं और एक प्लेट डाल दिया.
Right.
और एक प्लेट डाल दिया.
Yes.
तो that becomes volume. And आपने जो बोला डबल इंटीग्रेशन का कॉन्सेप्ट यहाँ आ सकता है.
Yes. Excellent.
वेरी गुड. तो मैथमेटिक्स को आप फिलोसॉफी से जोड़ सकते हो क्या? और डू यू अंडरस्टैंड व्हाट फिलोसॉफी इज?
Oh my God! Yeah, I mean this is a so fun part. It's a good exercise for your audience. Maybe you can Google. You can also try it. Google and open up Wikipedia page of anything like Osama bin Laden, Roger Federer, Sachin Tendulkar, whoever, which name you come to your mind, and you click on the first blue hyperlink of the Wikipedia page.
Okay.
Some other Wikipedia page will open, right?
Yeah.
You keep on doing that. So whichever Wikipedia page is coming up, you click on the first blue hyperlink.
You mean the first blue only? The first?
Yeah, first blue.
Specific first.
And then you will, Word. not the number.
Understood.
Yeah. So at some point of time, you will reach philosophy.
How do you mean? I mean, it's
Just
like
you can do it now. No issues.
no. Okay, let me first understand. It's like going down the rabbit hole. No, it's something else. Going down the rabbit hole is going to the citation reference and going in the under. This is not under also. You're going wider perhaps.
Yeah, I mean, point is the entire human construct is based on philosophy.
And what is your explanation here? No definition, not explanation.
Yeah, I'm coming to that. And second thing is mathematics is somewhat the quantification of philosophy. That's what I would say.
This is beautiful.
Now, I mean, beautiful or not, I don't know, but
representing philosophy in numbers.
Yes, exactly.
By number, I mean quantification also.
Yeah.
Okay.
So, I mean, as you said, sorry, what your question was connecting philosophy with math, right? So what happens in math? I mean, I'm not talking about the school level. If you are going up, first you are going to deal with a definition. There is some definition given or you cook up the definition. Okay. Then you have a statement. What is a statement? How does a mathematical statement will look like? If blah, blah, blah. So statement P implies then blah, blah, blah. Statement Q. So there are two parts of a mathematical statement. You have statement P and statement Q. Now, what is this P? This P is bunch of conditions. If these things are true, then the result is true. So there is some cause, there is some effect.
Which is precisely science.
Exactly. Now, what mathematicians do, or mathematicians are famous or infamous for doing, is the quantification of these conditions. Because how research is done, usually, if P is true, then Q is true. Someone published a paper. The subsequent researchers usually try to do, if P, some X% of P is true, can we get a better version of Q? So you try to optimize with the conditions up there. Okay. And this cause and effect is nothing but philosophy. What I believe is that this human existence, if you think about human existence, if you think about consciousness, that is precisely the manifestation of mathematics. We don't realize it much. Of course, nobody, I don't think anybody does that much before taking a step in daily life. But I believe that knowingly or unknowingly, somehow we are thinking in a graphical way.
So you have to expand this thing that you connected mathematics with human consciousness.
Okay. So yes. So
please take your time, and you can go anywhere. But I want to bring you that. I mean, I want you to come to that point.
Sure.
If these conditions are met, so what I said is correct. What you said is correct. I mean.
Okay, sure. So stop me whenever if you have any questions. I mean, that's the standard thing I tell in the class. But anyway, so there is something called Libet experiment. If you have heard about it or not, if you can Google about it. So Libet experiment basically deals with existence of free will. Now, what is free will? Before going that, think about from the mathematician's perspective. There is something called stochastic process, right? Stochastic. What is the process? Process is whichever evolving around you. That's a process.
Whatever happens.
Phenomenal. So this fan is moving.
It's a process.
It's a process. So I'm driving my scooty from here to quarter. That's a process. Anything that is happening and it is observable. Now you have to observe. Observe it. Meaning
who observes it? Like observer.
No, anyone can observe. Point is you have to interpret it in numbers. Okay, so that's where random variable comes in.
Again.
But I'm not going into the details. Point is the proposition. The proposition is every decision that human being takes is a combination of countably infinitely many binary decision.
Expand again.
Okay. Every human decision is a composition of countably infinitely many binary decision.
Your decision to come here.
Yes. For instance, I am here. So that's a decision. Meaning I may come, I may not come. Right? Now this, if you go back, it will go back infinitely back in time. But if you just restrict for the ease of discussion to, let's say, starting point from today morning, did I wake up right time or not? Did I take my breakfast at right time or not? Did I have my health was okay or not? Did I have my usual duties, the classroom teaching, my research, everything went well or not? Did I perform my familial duties correctly or not? At the end, finally, all these things culminated into, did I reach here or not? Did I drive my scooty correctly or not? Okay. So these things are all binary decision, meaning every decision will have the answer yes or no.
But that doesn't mean that. Let's say, did I wake up on time? Your answer could be yes or no.
Yes.
If it was yes, let's say you took that algorithmic branch and then you reach here.
Yes.
But even if your answer was no, probably you could reach here.
Probably, exactly. So there is an associated probability with it. And that's where the mathematical rigorousness comes.
Okay.
So in the morning, if you text me, so Neil, are you coming today or not? I'll say probably yes. Almost surely I'll be there. Something like that, right? If I say I will be there, it's a mathematically wrong statement.
Oh, really?
There can be infinitely many ways you cannot be here. I mean, because if you are saying I will be there, basically you are being a Nostradamus. You are predicting the future in 100% accuracy.
But then you are almost discrediting everyone who commits something.
Well, no, I'm not discrediting anyone.
Okay, that's a hard word to say, but when I promise something to somebody,
yes,
I shouldn't do that actually. Mathematically,
I'm giving credit that actually, if you have promised with 100% guarantee that you will do something and you have actually done it, it's a credit.
No, that means all the process that was there.
You have perfectly predicted every process.
Okay. All right. Oh,
okay.
Now this is good. Yeah.
Yeah. So there is no discreditation or anything.
Because
and
mostly for my answers are mostly yes or no, will or cannot. I hardly say may or probably. These are not in my lingo.
I usually put probably because I believe this is the age of political correctness, right? And if you want to be politically correct, you should always. That's my belief, by the way. It's very personal that you should always involve, in my opinion, probably, almost surely, because in mathematics has taught me there is precisely a mathematical phrase called almost surely. So for instance, if an event has 99.999% chance, it's an almost sure event.
It is not 100%.
It's not 100%, right? So yeah, that's what mathematics has taught me.
Like, yeah, if I were a mathematician, maybe I would have used these terms. So actually, in my school days, I think it was class 6 or 7, we were taught moral science as a subject as well. So there was one particular chapter whose concept stuck with me. I use the mantra still today. There it was said that words like yes, no, I will not, it projects your strength. What I mean is like this is something that एक है जो मैं स्टूडेंट्स को भी बोलता हूँ, और ये बोरोड है, मैंने ऑफकोर्स नहीं बनाया, कि if you say you can do it, you will do it. No, sorry, paraphrased. If you say you can do it, you are correct. If you say you cannot do it, you are correct as well. Both ways you are correct. It's very important what you say to yourself. So when I commit to myself what I'll do or what will I not do, तो जब मैं लोगों को भी प्रॉमिस करता हूँ ना, आई एम वेरी क्लियर इन यस और नो बाइनरी में. आप आएंगे, मैं बोलूँगा मैं आऊँगा. आप 6 बजे आएंगे, मैं बोलूँगा 6 बजे आऊँगा. आई डोंट गिव दैट स्मॉल प्रोबेबिलिटी, क्योंकि वो प्रोबेबिलिटी का वजह से मेरा अप्रोच बदल जाएगा कि मैंने थोड़ा सा लैक्सिटी का टॉलरेंस का जगह दिया. तो जब मैं बोलता हूँ 6 बजे आऊँगा, तो मैं 6 बजे पहुँच ही जाता हूँ कि कुछ भी हो जाए मैं 6 बजे पहुँचूँगा टाइप्स. I don't know if it's the right approach. Am I being too rigid with myself?
I think you are too harsh on yourself.
Okay.
Because, think about it. So, you are traveling from Itanagar to here.
Yeah.
In between in Nahar Lagoon, due to the excellent road condition, something happened to your vehicle. Okay? Not to you. Okay? Something happened. No, even not to your vehicle. Some other vehicle encountered some issues. And for that reason, your commitment at 6 p.m. got postponed.
In that case, मैं उसमें text कर दूंगा.
Exactly.
6 में नहीं पहुंचूंगा, 6:10 में पहुंचूंगा.
That's why I will keep. So what is important here? Yes, I will do it. Yes, I can do it. Yes, I cannot do it. What is important here, in my opinion, is the time horizon. If it is too far from you, you really can't predict it. If it is just after this, so for instance, let's say, shall we finish this conversation in 20 minutes? Most likely you will say yes. Most likely I will say yes. If my wife asks, shall we go for a dinner tonight? I will say yes or no. There I will not say probably. But if it is too far, let's say again, same thing. You are asking, can we have the conversation 1 week down later? I will say probably. I have to check my calendar. So far, yes, like that. Right? So time horizon matters in that case.
Yeah. The limit matters.
Yeah.
Yes, thank you very much. This is a new insight, and probably next time, probably say I'm saying this now. See, it has come to my lingo now.
Yeah. I mean,
I'm already influenced. What is that called? Induction हो गया मेरा थोड़ा सा.
Yeah.
So continue with what you were saying. Connecting mathematics with life.
Right. Mathematics for life. So what I believe, I mean, mathematics imparts one of the strongest lessons to life is the rational structure, which I believe is the most useful gift from mathematics to everyone, even if you are not using mathematics in your day-to-day life in the hard sense, right? Even if you are not playing with numbers. Because I mean, being an Indian, being grown up in this society, I have seen that our Indian society is somehow, it is defragmented in lot of different, with respect to lot of different features, right? And one of the key features being the religious fanaticism, extremism, and so on and so forth.
Right.
Now what happens that people ask, like, do you believe in God? Do you believe in this God or that God, and so on and so forth? Now I believe if you are a mathematically enlightened, or if you have tasted the mathematical thought, if you have imbibed in yourself, then you should ask in return, what is your definition of God? Because as soon as you say what is your definition of God, then you are first realizing that the definition of God can be subjective. Your God can be different from mine, my God can be different from his, so on and so forth, right? So first you are prioritizing that there is subjectivity around the notion of God. That's number one. Number two, as soon as you say one definition is fixed, right? You have stated the definition, then you can argue, you can take your next step based on that definition. Because in what does mathematics teaches us? Mathematics set one definition. I mean, that's the golden approach of mathematics that I have found extremely interesting. You have a definition, then that definition has a lot of implications.
Yeah.
Right?
Yeah.
And then you play with the results of these implications. Right? So at the end of the day, you have a graph-like structure of lot of cause and lot of effects.
Yes.
So you draw all the interconnected edges. So you can analyze a cause and effect situation much more clearly.
Yes.
Right? So for instance, if someone is saying, again, Virat Kohli example, let's say Virat Kohli is not getting runs because of this, and he or she mentions one particular reason. Now, if you are a mathematician, you will say, not true, false statement. It might be one of the reasons. There might be other reasons. Most importantly, the reasons should be listed like A, B, C, D, E.
Okay.
The last reason should be unknown. That's where you are somehow making the room for stochasticity. That's where you are making room for luck. Things in our daily life which are not controlled by us.
Or which are not understood by us, perhaps.
Yes, of course. We cannot understand by us, of course. So mathematics does not mean that I know everything, but somehow it is giving you the room that I may not know everything. There may be 100 of things that I don't know, but I have to acknowledge that I don't know this. Okay. And having a clear picture of this cause and effect is the utmost lesson that mathematics can impart.
You brought God in our discussion.
Oh.
So I almost refrain from speaking about it,
Oh.
but yes, still, from the mathematics lens of discussion,
Mm-hmm.
you see, let's say the Abrahamic set of religious people,
Okay.
they still say that God is unknown, but their messengers are known properly,
Okay.
right?
Mm-hmm.
You understand what I'm saying?
Yeah,
right?
yeah, yeah, yeah.
So Lord Jesus, Prophet Muhammad, they were messengers of God.
Yes, yes.
So the God is still in the unknown terrain,
Correct.
but the messages are very clear,
Correct.
right?
Yeah.
And if you go to the eastern side,
Mm-hmm.
let's say Hinduism, Buddhism, Taoism, whichever ism here, this side, they're like they don't have a messenger per se, but they again say that if you want to look for God, maybe you look within yourself, you might find an answer within you.
Correct.
Then again, the God is unknown there.
Mm-hmm.
So can mathematics ever approach nearest to God
Okay.
mathematically?
Mm-hmm.
Because lately, I don't know, I saw a YouTube video of Japanese astrophysicist who was Michio
Michio
Kaku.
Kaku.
He almost was going there that through mathematics he can define God.
Okay.
So, what's your comment on that?
Well, first of all, I'm nowhere close to Kaku, so and of course, I can't comment on that particular topic because I have not that expertise. That's number one. Number two, the things that I have studied so far in mathematics, whatever concepts, notions have been introduced, explained. Um, there are two things which, in my opinion, close to my God, my definition of God. One is there is something called singularity.
Okay.
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 And second is there is something called stochasticity.
See, you have been using this word. थोड़ा सा
Okay.
थोड़ा
So for lame persons, stochasticity essentially means things that are not predictable. So the opposite word of stochastic is deterministic. Deterministic means you can predict. Stochastic means you can't predict.
Thank you. अभी आगे बढ़िए.
Okay. Easiest example, Nifty 50 index. Everyone understands money, so that's it. Okay. So it has a lot of oscillations. Nobody knows what will happen in the next moment, but it is still happening.
It is happening.
Okay. So that's what stochasticity is. And that's a perfect example of the attributes of the usual notion of God that is somehow omnipresent in society.
आप फिर से repeat कीजिए. I almost disturb you.
Oh,
I
sorry.
disturb your flow. Yeah, you say singularity and
Oh, yes. Singularity and stochasticity.
okay.
These are the two things, two mathematical constructs which are somewhat closely relatable to popularized version of God, notion of God, the unknown thing. Or so in the Abrahamic thing, you are saying the unknown God, and in the
Eastern side.
Oriental side, the notion is introspection.
Introspection.
Who am I?
Who am I? Yes.
Right. So the self, the consciousness. So singularity means it's a point around which you have no data, no information. So in terms of astrophysics, that's black hole, right? So people are still trying to dig up data around black hole. So there is no data coming out, right? So that's singularity, which is kind of God. Stochasticity, you can't really predict.
You can't really know.
Yeah, you can't know.
No, knowing is still higher term. You can't really predict.
You can't really predict.
You can't
Yes.
really imagine.
I mean, again, it's a mathematically false statement. You can predict up to a certain level. I mean, there is percentage probability of error. Now you are talking in terms of how much error you can make.
Actually, I get you, because yours is infinitely similarly small, or it could be infinitely
Large. Yeah.
So there's no boundary.
Yeah, boundary
There's
is
no
there.
akar.
Yeah.
The so-called if you can imagine God,
Hmm.
then that imagination cannot be God. But because God cannot have you cannot fix it within your limited understanding.
Yeah.
I mean, what I'm saying is कि निराकार कहते हैं ना, आकार ही नहीं हो सकता.
Yeah.
So it's not a material thing that you can actually imagine.
Correct.
So mathematically वो possibility है. Otherwise किसी तरीके से explain करना मुश्किल है.
Excellent. Yes.
आप
I
समझे
agree
ना
with
मैं
you.
क्या बोल रहा हूँ?
Yeah.
Okay. Wow. आज क्या क्या revelation हो रहा है मेरा साथ भी आपसे बात करते करते. See, I hardly speak about God or hardly think about God, but यही चीज़ आपने जो बोला, unknown thing, वो मेरा दिमाग में मतलब मेरा लिमिटेड बॉक्स का ऑफ अंडरस्टैंडिंग या मेरा इंटेलिजेंस में घुस ही नहीं पाएगा, तो इसलिए मैं नहीं, I don't even go there.
No, I mean, these are the things should be discussed properly, because you see, as soon as people talk about God, they said we don't know it, we have not seen it, etc., etc.
What can they say? It's a safe answer, no?
But the thing is, we are dealing with the same things, stochasticity and singularity. We have not seen it. Nobody knows what is happening around there. So it's a safe thing to discuss about. And most importantly, again, this rational structure of, you have a definition, then you have a proposition. Proposition means there is a precedent, there is an antecedent. Statement P implies statement Q. This sense of implication. Once you have dissected any, let's say, regular conversation, the faster you dissect any regular conversation, simpler your life is.
Okay.
That's my opinion.
Example please देना, तो मैं समझ तो गया, लेकिन थोड़ा सा reinforce करो मेरा समझ को.
Of course. So let's see, moral science in your school days, there were a lot of good things, right? Meaning you should not be jealous about others.
Okay. Yeah.
You should not do bad.
You shouldn't be a sadist kind of stuff.
Yeah, exactly. But still, as a human being, what bothers us? What are our most painful things? Jealousy, anger, greed.
Are you saying that every human being will have these?
May have this.
Okay. You will never go with.
I will never make a I mean, I will try to refrain from making a deterministic statement.
All right, well noted.
Because it is either almost surely possible, almost surely impossible, or it's a statement. It's okay. So human beings have may have lot of ripus, the enemies, right? There are shudder ripu in the Oriental thing. Now, point is, so again, talking about the probability. So there is this random variable, right? And you have something called expectation of a random variable, right?
Expectation should be biased.
No. Expectation essentially means it's like the mean, the average.
Oh, okay.
So you have 10 students in the class. They are getting 10 numbers. Now, what is the average number? That means that's the expected numbers, right?
Yeah, understood.
Now, our happiness or our sadness, how it comes? When something happens and it does not match our expectation.
Okay.
Then we become either happy or sad.
Yes.
When the value of the random variable is more than our expectation, so something better happened than our expectation, we become happy. Something sad, I mean, if something lower happened than our expectation, we become sad, right? So that is variance.
That is variance, correct.
Right.
Technically, it's variance.
But in math, what happened? You are taking not only the random variable minus the expectation. You are taking random variable minus expectation square. Okay.
Okay.
You are taking expectation of that, then you are getting variance.
Yes.
So, if you have studied math, or if you have understood math, if you have somehow taken math your inside, then I believe you should not be that much sad. You should not be jealous with others. What is happening with others? What is happening with your expectation? Because you are expecting something. In some game you will win, some game you will lose. It's a zero-sum game at the end of the day, if you are looking at the big picture. All right?
Zero-sum game, correct.
Yeah. The same thing is given in the law of large number, in probability.
Say it.
Okay, so again, without going into the detail, if you are looking at coin toss, Uno games.
मुझे नहीं पता क्या.
Okay, you know. Okay, you don't know Uno games.
मैं games नहीं खेलता, मुझे नहीं पता.
Okay, so you have seen drunk people.
Oh, I got drunk myself that time.
No. You can't get drunk because you have to observe. You have to be the observer.
Achha. Okay. In this case, I cannot be an actor.
Yeah.
Okay.
So you have to see drunk people.
I can make you drunk and observe.
No. Then you'll be in trouble. Tomorrow I have class. So you have to observe the trajectory of a drunk people from bird's eye view.
Okay.
From the high up. And this fellow, he is stumbling or she is stumbling left, right. Maybe left 3 step, right 4 step. again left 5 step, then probably straight line, so on and so forth. Point is, if
And
you
probably stop somewhere.
probably stop somewhere, no issues. Point is, if you are looking at from very high,
The bird's eye view,
in
as
the
you mentioned.
bird's eye view, in the long range, in the long time horizon also, you will see that fellow has traversed roughly along a straight line.
Yes.
Okay, that's the fun part about the game Uno. I mean, those of your audience who played Uno, it's almost a never-ending game. It goes on like this.
Okay.
Okay. Why? Because the moment someone is about to win, all of the other players, they kind of gang up to make this person to lose. So immediately the balance is shifted. So in a long range, in a long time horizon, Uno takes huge time. Similarly, this drunk people walk. It is along a straight line.
What was the point, by the way?
The point.
I forgot actually. Because I am engulfed. My brain is thinking of so many things at this point.
The point was this philosophy of life and philosophy of math.
Oh, okay.
Right.
When you give that the drunk wala example, this philosophy is everywhere actually. You see, and mathematically, of course, you know what a circle is. It's just straight lines and infinite straight lines. And this certain distance from a certain fixed point, and it becomes a circle. It looks like a curve to us, but that's not a curve, right? It's a straight line actually. Too many straight lines put together.
Yes, straight line of infinitesimally small length.
Yeah. Right. And then when you said the Uno game thing, when one is about to win and the entire gang comes and pushes him off board.
Yeah.
So that's how even life works. Like when something is in equilibrium state, there is an tendency of entropy, and it will shoot off to unstable zone.
Correct.
And when something is unstable, then some agency comes and brings
it to again
equilibrium, and this wave continues. That's what life is, right?
Yeah.
We cannot be stable all the time. There won't be any life.
Yeah.
And we cannot be chaotic all the time. There won't be any life.
Correct.
Ultimately, it's a straight line.
Very true. And that's why, I mean, that was the actual point, that not philosophy of the philosophy and maths connection, but rather what happens if you learn math and you approach life, right?
So what I understand now is, at least for mathematics, this is the first time, by the way, I'm speaking with a mathematician.
Okay.
You consider yourself not to be a mathematician, but technically you are a master's, bachelor, master's, and PhD in mathematics.
Yes, that's correct.
You had some stint in Germany as well. What were you doing there?
So
okay, your educational background. Oh, come on, man. I haven't asked about it. Sorry.
Okay, so I did my bachelor's from Ramakrishna Mission Vidya Mandir, Belur Math in West Bengal.
Okay.
Then I pursued my master's from Tata Institute of Fundamental Research, Center for Applicable Mathematics in Bangalore.
Okay.
Then I did my PhD from University of Oslo, Norway.
Okay.
Then I did my postdoctoral research tenure in Darmstadt, Germany.
Okay. All right. And now, is it your first?
No. Before joining NERIST, I was an assistant professor at Vellore Institute of Technology. Vellore
VIT.
campus. Yeah, VIT.
Okay. Fine. So, you are a mathematician that way, at least in the academic structure.
Okay, if you say so.
Yeah. I mean, I could be a mathematician in my approach towards life, but academically, technically, I am not.
Okay.
Yeah. And drawing the same parallel, I would assume all the mathematicians to be very rational in their mindset, and for them to have at least a higher degree of IQ. They need to have, if you can break down any process into the binary being, yes or no, it's all algorithmic. And algorithmic gives you structure, and people in general have that tendency to find the structure easy.
Yes.
Right. I give example to my students as well. जो ताजमहल देख के डरने का नहीं, सिर्फ 2 ईटा जोड़ने का सीख जाओ. If you know how to combine 2 ईटास, ताजमहल बन जाएगा. तो ये 2 ईटा जो होता है, जो मैं तो उसको जो इंटीग्रेट किया हूँ, इंटीग्रेट किया हूँ, आप उसको डिफरेंशिएट करके ताजमहल को तोड़ के 2 ईटा मिला देते हैं.
करेक्ट.
राइट, वही हुआ ना? हाँ. तो वही मेरा कहना है, लेकिन फिर मैथमेटिशियंस भी तो ह्यूमन बीइंग्स ही होते हैं.
Sure.
उसमें आपने जो बोला वो सब तो शायद होना पड़ेगा. जो
Well, I mean, there is this thing called, I mean, it was there in 11th standard and 12th standard, ideal gas versus real gas scenario, right? well, that's our expectation, that we should be the ideal or should be the
Your explanation is still mathematical.
yeah, I mean, so
good.
you said that mathematicians should have the good higher IQ.
At least that's how I should want to see it.
Exactly, I would also. I definitely love to see mathematicians being more stable than anyone else.
Yes.
Because stability is the key, that is in my opinion. Okay. And if you have understood mathematics, that's the first thing that mathematics teaches. Rationally think, analyze every situation. Solution is kind of ubiquitous.
That term again, what is it?
Ubiquitous. Present, omnipresent.
Okay.
Yeah.
So mathematics को कभी holy books में कभी describe हुआ है? I don't know if you read any of the holy books.
Well, I have read holy books, but not explicitly. I haven't seen much explicit mathematics being there. But again, yeah, philosophy is there, but I have not seen any explicit mathematics.
Which holy book you read?
I have read Gita.
गीता में मैथ्स का बारे में कभी वर्णन नहीं हुआ, क्योंकि अगर मैथ्स इतना ही यूनिवर्सल है तो मुझे लगता है होली बुक्स में होना चाहिए. मुझे ऐसा लगता है. Some expression of mathematics.
I don't believe so, because in my opinion, again, it's my personal opinion, the job in literature is to explain simple concept in 1,000 words using 2,000 analogies.
Okay.
Whereas in science or maths, the job is observing 2,000 analogies or examples, trying to draw one crystal clear, crisp conclusion.
Okay. No.
So that's one thing. And holy books, I believe they are good part of literature.
No, sir.
I don't know.
Holy books are rationals.
Okay.
From the lens of a people, that community.
Yeah. I mean, see, I don't know.
Because मैं क्यों बोल रहा हूँ? When you say stability, मुझे ये वर्ड बहुत स्ट्रॉन्ग लगता है, स्टेबिलिटी. इनफैक्ट जब भी मैं क्लासरूम घुसता हूँ ना, सबसे पहले मेरा वो ये होता है, पहला सेंटेंस सो कॉल मेरा पहला मुंह से जो निकलता है, प्लीज stabilize yourself in the classroom. Only then I can start. You cannot be random right now. तो मेरा चीज़ कुछ जाएगा ही नहीं. So for you to grasp anything, you have to first settle yourself. So
absolutely, I agree.
हाँ.
I agree.
तो आपने ये वर्ड स्टेबल यूज़ किया, इसलिए मैंने ये यूज़ किया, क्योंकि I think I heard a very Sanskrit term called स्थिति. हाँ, तो ये तो होली बुक से निकला हुआ चीज़ है, तो इसलिए मैं ऐसे कनेक्ट करने की कोशिश कर रहा हूँ.
Sure. I mean, it
आप सुना है ना ये क्या है?
Yeah. So it basically deals with equilibrium. Okay. It's, I think, in the chapter 2 of Gita.
There you go.
Gita.
So,
it's in Karma Yoga. It's beautiful thing. So Krishna is kind of tutoring Arjuna about life lessons, so on and so forth. In between, he put this word called sthitati, and Arjun, being a good student, asked immediately what is the sthitati. So Krishna explained. I think it is the 55th or 56th shloka of the second chapter.
It doesn't matter.
But anyway, dukheshmanu bignamanaha shukheshu bigatas priha bita raga bhaya krodha sthitadir muni ruchyate. Meaning, dukheshmanu bignamanaha, you are not much moved with sadness, dukh. Shukheshu bigatas priya, same as with sukh, happiness. So you are not moved much with happiness, you are not moved much with sorrow, you are not moved much with anger, fear.
You are stable, basically.
Yes, all the human emotions, it does not affect you much. No one is saying here that you should be totally unmoved, because then you are taking humanity out of the window, right?
So it's
you should enjoy. You should enjoy. No
you are almost approaching the straight line, but not exactly the straight line.
Yeah, there is a very small perturbation around the straight line.
Okay. If you go closer and closer,
but if you look at from the very top, it's straight line.
Yeah.
So that is somewhat, let's say, attaining a steady state, if you want to speak it in a mathematical terms, this karma yoga essentially speaks about steady state. And there was this thing that karmanya badhikaraste ma phaleshu kadachanam, meaning you go and do your job, you don't care about the fall result, right? That means the random variable should be there. You are not much worried about the expected value of the random variable.
But you have to do the process.
Yes, you have to do the process. You have to let the simulation go.
So see, you connected now. That's why I had a feeling that there will be some connection somewhere.
Okay.
I didn't know which book you read, but
Yeah,
then
okay.
you have read Gita somehow.
Yeah.
Okay, you remember the sloka.
Yeah, that was during our bachelor's. So
Why did you have to read it? It was personal interest or someone forced you to read?
no, I mean initially it was forced. I mean, I don't think nobody reads this book without force at the very first. So our college, it was a Ramakrishna Mission college, and
that way.
every day you have to wake up at 5 o'clock. Then there is the prayer, morning prayer. There was and in the evening there was this Gita reading. So initially it was very boring, I agree, but and the good part is that time I was starting my bachelor's in mathematics, and unfortunately in India the situation is the jump of mathematics from +2 to bachelor's is way more than any other subject.
Oh, really?
Yes. So if you are doing +11, 12 in your physics, I mean, you are studying physics in your 11th and 12th, the physics that you are reading in your first semester and second semester is much more closer than the mathematics that you are doing in your 11th and 12th compared to the mathematics you are doing in your first semester.
Okay. It's all the more big jump.
The jump is huge. It's totally opposite thing you are doing.
Oh, okay.
So that's that's something that people should be aware of. Like you are good in math in 11, 12, then you took the math in 11, 12. It may not play out that well. I mean, there is a chance.
Okay. So I think we have hit the 1 hour mark.
Oh.
I really had a very, I would say the discussion for me, at least sitting from this part of the table, for me it was very profound because मेरा कुछ पुर्जा खुल गया दिमाग का.
Okay, glad to hear that.
और भी मैं मैथमेटिशियन लोग से बात करना चाहूँगा, इंक्लूडिंग यू अगेन, क्योंकि मुझे इस तरीक़ा से सोचने का मन है.
Okay. Sure.
Is there anything we can discuss as the last conclusion नहीं बोलूँगा, फैगन में जो होता है, आपका कुछ है माइंड में, कुछ डिस्कस कर सकते हैं, या आपको कुछ सवाल है मेरा ऊपर की lay person हिसाब से मैं बात कर रहा हूँ.
I don't have any question, but I would really like to thank you for this opportunity.
Okay.
I mean, see, not every day you can talk like this. That's one thing. Okay. Because I'm going there in the class, although students may or may not speak that much, they are probably afraid, they are probably shy, but still somehow this discussion should be happening in the background.
Okay.
Somewhere. And I mean, it would be nice to see you connecting mathematics in your mechanical engineering.
Yeah,
because
that I can.
You said that you have known formulas.
Yeah.
So what do you mean by known formulas?
By known formula means these are all empirical based, right? I mean, tried, tested, repeated. It's just like the bird's eye view thing.
Okay.
We are not going to the zoomed in perturbation to be seen. We take that straight line as it is. That in Newtonian physics that we have. Like yours is more quantum.
Yeah.
Ours is more Newtonian. We consider mass as mass.
Okay.
We consider even let's say fluid to be following the concept of we do a lot of assumptions basically.
Yeah.
Engineers do a lot of assumptions. We take fluid to be continuous mass, which is not. Every atom has gap between it, between these two. I mean, two atoms have gap between it. All right.
Yeah.
Because nothing can come in contact because there's some repulsion when they come. There's a small bond length.
Sure.
And within the atom itself, there are quark particles. What's the infinitesimal particle.
Right.
Basically, there is no matter if you think it that way, because there is gap everywhere.
Right.
But as mechanical engineers, we assume that अगर ये 1 किलो है तो 1 किलो का मास है, बात खत्म इधर है. We don't go beyond that.
Understood. Yeah, I mean,
एक सेकंड सर, हमको तो अप्लाई करना है कुछ बिल्डिंग बनाने के लिए, मशीन बनाने के लिए. तो हम अगर उसका क्वांटम स्टेट में चला जाएगा तो हम नहीं बना पाएगा बिल्डिंग. हमको कुछ ना कुछ एज्यूम करना पड़ता है, क्योंकि आपका अंदर में you yourself as human being has billions of concepts within you. But for me, you are a mathematician today.
Okay.
ओवरऑल पैकेज वो लेके रख दिया, तो वो पैकेजिंग हम established formula हम उसको मानते हैं.
Sure.
That's how we do it.
Yeah, I mean, in mathematics, we have this microscopic and macroscopic structure of a process or a system, right? So, in microscopic, you are breaking it down. In macroscopic, you are looking at the larger picture. So, yeah, it's,
Like, so let's say the Newton's law that we say, वो अगर हम उसको न्यूटन्स लॉ हिसाब से नहीं देखेंगे, ना न्यूटनियन फिजिक्स लेके नहीं देखेंगे, तो हम वो न्यूटन्स लॉ क्रिएट नहीं कर पाएंगे.
Yeah.
That is the thing, no?
Agreed.
So that is, I think that suffices your question.
Yeah. Sure. Yes, of course. Yeah.
Sir, you said you met my friend in Darmstadt, right?
Yes.
So उसने एक बार मुझे कुछ बोला था. I don't know if it's relevant to my viewers. फिर भी I'll just bring it on the table. I didn't understand what he was saying because वो तो research scientist है. In his lab, I think he's in Ghent right now. कुछ accelerator laboratory में है.
Okay.
कुछ electrons, protons का movement को study करता है. He's trying to understand so-called life, consciousness through matter, through electrons and all. I was like, salute, आगे बढ़ो और मुझे बताओ क्या मिला. क्योंकि एक लाइफ बाय इटसेल्फ और कॉन्शियसनेस बाय इटसेल्फ को मैटर के साथ कनेक्ट करना भी थोड़ा मुझे डिफिकल्ट लगता है. ऑल्दो वी से दैट इट्स ऑल मेंटल एंड इट्स मतलब ब्रेन में न्यूरॉन्स जब सिनेप्सिस होता है, जब फायर होता है, तब जाके कुछ एक कॉन्सेप्ट बनता है. लाइक योर नेम इज नीलब्जा इज वन न्यूरॉन फिक्स्ड हियर. आई हार्डवायर्ड इट बार बोल के, तो इट हैज बीन फिक्स्ड हियर. तो ये नीलब्जा तो एक्चुअली इट्स नॉट अ मैटर, इट्स जस्ट अ साउंड. आई मीन इट्स अ कॉन्सेप्ट, लेकिन वो कॉन्सेप्ट का जो जिस पे स्टोर्ड कॉन्सेप्ट है वो तो मैटर है, माय ब्रेन. तो ये और फिर ऐसा करके फिर ये एग्जैक्टली लाइफ क्या होता है बोल के एक बहुत गहरा सवाल जो है. माय फ्रेंड, योर फ्रेंड राहुल सिंह वाज सेइंग कि ही इज प्रोबेबली, आई डोंट नो इफ आई मेकिंग करेक्ट स्टेटमेंट, इफ ही वॉचेस वो मुझे करेक्ट कर सकता है और आई जस्ट ट्रिम दिस अप. बट उसने ऐसा कहा था कि हाइड्रोकार्बन मिलके ऐसा पॉलीमर बनता है, फिर ये बन के फिर ये लोग का बीच में मन करता है कि और ग्रुप में बनो, फिर ग्रुप में सस्टेन करने के लिए जैसे कि चलो भाई ये करते हैं, करके ऑर्गेनिज्म बन गया. ऑर्गेनिज्म बन के हम बन गए एंड फिर लाइफ ऐसे ही आ गया. फ्रॉम मैटर, आई मीन अगर हिंदी में बोलते हैं पुरुष एंड प्रकृति कहते हैं, तो कोई पुरुष पहले आया कि प्रकृति पहले आया? प्रकृति इज द नेचर, प्रकृति इज द मैटर, पुरुष इज द कॉन्शियसनेस. तो पहले कॉन्शियसनेस आया, फिर मैटर बना, या मैटर बना फिर कॉन्शियसनेस बना. तो जो मेरा फ्रेंड जो कर रहा है वो मैटर पे काम कर रहा है कॉन्शियसनेस तक पहुंचने के लिए. खतरनाक वाला एक रिसर्च चल रहा है. तो
That's quite interesting. I mean, I think it has been topic of research among the if I'm not wrong, then certain section of neuroscientists. They do a lot of research work based on this consciousness, because I don't know the entire spectrum of this arena of research, but for sure some of the neuroscientists, they visualize consciousness as nothing but potential.
By potential you mean the
electric
spark?
Electric potential. So because you have the synapse in between, but they don't connect each other, right? You have the synaptic fluid. So how they are connect, I mean how the information is getting passed on as charge, right?
Yes.
So far, I mean, I have not understood it, I have not realized it, but what I gathered that there are modeling, there are attempts of modeling of I mean this neural spark, how they evolve. So how consciousness transfers, if it is transferable at all. These research works are happening, that's for sure. And yeah, of course these are interesting, very interesting at the face of it, for sure, and definitely much more involving if you go to the detail. So
we have just opened a new dimension to speak, but neither you nor me.
Yeah, I'm definitely not capable. I'm definitely not an
We
expert.
still have some क्या बोलो stupid discussion.
Yeah.
जैसा कि मैं बोल रहा हूँ, there should be difference between being sentient and being conscious. Right? Being sentient मतलब जिंदा रहना.
Correct.
Being conscious means aware रहना.
Yes.
Right?
Yes.
तो जो AI होता है वो तो थोड़ा conscious हो रहा है क्या? Awareness आ रहा है उनका? They are not sentient being any which ways.
True. I mean, that consciousness is coming, Whether they will be conscious enough to be a human being, that I'm not yet sure of.
For human being, they need to be sentient again.
Yes,
Life
exactly.
होना पड़ेगा.
Exactly. So that's one thing. I mean, they have been lately quite powerful.
Yeah. In
They are
the
not
in the
100%.
domain of awareness,
Yeah.
they probably are more aware than us. No, okay.
I won't give that much credit immediately. Yeah, I mean, still.
आपने मूवी देखा ना रोबोट
Yeah.
चिट्ठी
Yeah. Yes.
Look at that man.
So,
कितना aware था वो.
I mean, that was a movie.
Yeah, what possibility is there?
Exactly.
What are we? We are just algorithm of the data that has been fed to us. What else are we?
True.
तो वही data उसमें डाल देगा तो.
But again, there is some stochasticity involved, right?
Yeah, it's okay. Yeah, correct. That's what makes us. That's what should make us human being.
I mean, do you have any blood diabetes, cholesterol?
I know. I'm a
Hopefully you will never have. But I have seen many people who has all of these at the very high level, but still they cannot refrain them from eating sweets, charts, so on and so forth. If we were 100% algorithm, we will never eat it.
That makes sense. That makes
Right.
a lot of sense.
At some point we're like, let's try it once.
ये वाले एग्जाम्पल्स है ना, मैं अपने स्टूडेंट्स को कभी कभी बोलता हूँ कि मिठाई खाना नहीं खाना इज योर मेकिंग, लेकिन एक बार मिठाई खाने के बाद इधर जो होगा इट हैज गॉट नथिंग टू डू विद यू.
Exactly.
तो हियर द साइंस कम्स. खाना नहीं खाना हैज नो साइंस.
Yeah.
यू.
That's your choice.
सो विद दैट सर खत्म करते हैं.
Okay.
बाय बाय.
Thank you. Bye bye.
ओके.